You invest €1,000 at 6% per annum, compounded quarterly. How long will it take for the investment to increase to €2,000? So this is a compound interest question. There are other ways to do this. I would recommend, given that you're going to do much harder things than compound interest over the course of the program, there is a formula for compound interest in the formula book. So I think that the way that puts the least stress on your revision or anything like that is just to know that there's a formula and know how to use it, and use your calculator skills. So the formula book, it says FV equals PV times 1 plus R over 100k to the power of kn. And then it defines all these things. So FV is the future value, as in how much will be in the account at the end. So FV future value. PV is present value, which is normally what you start with. N is the number of years. K is the number of compounding periods in a year. So it's the number of compounding periods per year. And so we've covered FV, PV, N and K. What we haven't covered is R. Now R is the interest rate, and that's an annual rate. It needs to be annual because all of these numbers in here take into account the fact that you might compound quarterly or monthly or daily, something like that. So it's an annual interest rate. Okay, so we say you invest €1,000 at 6% per annum, compounded quarterly. How long will it take for this to increase to €2,000? So what we have, the 1,000 is the present value. The future value is the 2,000 because we want it to increase to this in the future. 6% is the R, the interest rate per annum, annually. Compounded quarterly is where we get our K from. If it's compounded quarterly, that means there's 4 compounding periods per year. So K equals 4. So we now can form this equation. So we want future value, so 2,000, to equal present value 1,000. 1 plus R is 6 over 100. K is number of, it's 4 compounding periods per year, number of compounding periods per year, and we have Kn. So K, it is the how long that you don't know. So N can be N. K, we just said is 4, so 4N. So if you look at this equation, it's quite complicated, but the good news is there's only actually one unknown, which is quite nice. So what we're going to do, and there are other ways to do this, there's even a built-in finance solver, but like I say, I think learning how to use the finance solver is probably going to tax your long-term memory more than just using this formula, because it does actually define every variable for you. So we're going to do it in, if you use a graphical approach, I think it's good because it's just so transferable to lots of other things, and you probably already know it from GCSE. So I'm going to plot 2 lines. I'm going to plot 1,001 plus 6 over, and I might call that 400 to the 4x, and I'm going to plot y equals 2,000 as well. I'm going to see where they cross, and then I'm going to get an n from that. So we go to our calculator, menu and graph. Oh, excuse me. So menu and graph, and we've got 2 things in there that I don't want. So get rid of that and that. So it needs to be 1,000. Open a bracket. 1 plus 6 over 400 times 4, so to the power of 4x. So that's the first line. The second line is a lot simpler, it's just y equals 2000. So then we're going to execute and draw, and you'll find you can't see anything because the window's out. So obviously the y bit is the easiest thing to think about. We're looking, when does this thing cross 2000? So we need to go up past 2000. So I'm going to go up, Shift V window. I'm going to make sure the y max, well, y min of -3, I suppose. I quite like, if you can see the x-axis, it's okay. And you could start at 1000, but I'm not going to. So I'm going to go up to 2500, 2500 on there. And for the x, well, it's probably, if it's going to take a few years for this to happen. So let's, I don't know, let's try, say 20 years. And if it's wrong, we can just change. So execute, execute, draw. And you can see an intersection. So remember, these are working. So if you use a graphical method, you want to show the examiner that you did it properly. You can kind of draw that, and you can draw that. So I might say, well, that was f of x. Oops, excuse me, that was f of x, and that could be g of x. And I could say, well, this was f of x, and this was g of x, and I'm looking for the intersection. So second, or shift G solve. I'm looking for the intersection between the 2 points, and it tells me that that is 11.6. So this point is 11.6, and I suppose because I'm showing a graph that I understand graphs, the y value is 2000. So because its equation, I had the unknown of n, and I've set this whole thing up, and we've just used the x. So this is actually now the right amount of years. So n needs to be greater than 11.6 years. So given that it's compounded quarterly, you've probably got to go beyond 11.75, I guess. Which probably means 11 years and 3 months. And 3 months.